we had it set up for 100 milliliters of water. By adding any more than that, it wouldn't work. The water will just stay out. So this is one of the things you could use for, why measurements are important, why it's very important to be specific and accurate when you're measuring everything.
In fact, I just used this with my class on yesterday when we were talking about measurements. If I would have put 10 milliliters in there, same thing, it wouldn't have pushed enough to push against the walls and keep everything in there.
At Aldi, they have this thing called squishy bag, and it's kind of almost, it seems like this is the same kind of concept.
Yeah, actually, this is used a lot in many different aspects. One of the experiments that's going to come up next, they use it in a lot of movies for like snows. This one actually can use it for like water or for a fireproof gel, or they'll put it on the actor before lighting them on fire. The water in there will actually absorb most of the heat, so they can do their stunt and then be put out without any fear of being hurt. Next, I'm going to turn it over to Caitlin.
Can I ask something possible? I've done this experiment with when I do Polymer lab, and I talk about cross-linking. And so I a lot of times make this a magic trick where I make the water disappear and then I make it reappear by adding magic crystals and have them do the whole abracadabra. So I talk about how the sodium actually is like they break up their little like, and sometimes I'll do where they'll form a human chain like the polymer. They'll walk around and show how just a straight long chain, and when you cross-link it, you can't move. And then I have a couple kids come in and karate chop. They love the karate chop of the links. And so this shows it goes back.
And the magic crystals,
they think it's milk.
The magic crystals are salt, right?
Right, yeah. So the sodium in the salt breaks up the cross-linking, and
It's also
turns
a
it back.
competitor for the sodium.
Right, so it winds up being, the kids like that in terms of a magic show. They'll ask you what it is. They'll think it's milk, that you've made milk, but you explain that no, it's still the diaper material. So. But yeah, so that's a fun variation to do for polymers.
Yeah. I'm going to turn it over to Caitlin to continue on.
Alrighty. So, keeping with the theme of the polymers and super absorbent polymers specifically, I'm going to have you guys get out like your little deli-looking container and a little tube. Huh?
No, they have deli containers. I traded them.
Okay. You should have a deli container with a little red capped tube in it. This is anhydrous sodium polyacrylate, so basically the same stuff that Matt just used, but it's in a little bit more coarse form. And what you can do is we're going to have you pour the whole vial into your little deli container. Kind of spread it out in that container a little bit. And now, depending on what kind of effect you want, you could add all of your water at once, or you could have your students add their water a little bit at a time. So I'm going to have you fill your graduated cylinders with another 100 milliliters of water. And depending on the effect, like I said, if you add all 100 milliliters of your water at once, we call this fake snow, it'll puff up really, really fast and you'll get a really large effect, more of like an ooh kind of reaction. Whereas if you add the water slowly, it's kind of like, okay, it's getting there, and then finally they'll get to the full effect. So it's up to you. I like to add all of my water at once, but you can go ahead and give it a shot.
Go ahead and add your water.
I think there's enough. If you stir it up with your finger, you should see that it's it's different than the WaterLoc gel, in that it's more fluffy.
So the difference is the coarseness of it?
Yes, this powder is a lot more coarse than the WaterLoc gel. And if you keep fluffing it with your fingers, it'll get even more fluffy. Right now you should notice that it's room temperature, but if you let it sit out for a couple of minutes, it'll actually get really cold because it's an endothermic reaction. So these polymers are super absorbent, and they're actually called polyelectrolytes. And the charge on their chain is what allows them to be really soluble in water. And as you saw, if you add more water, it'll actually kind of take away from its fluffiness and you'll get more of a gel. And eventually it'll just dissolve completely. But this is the polymer that's, well, I guess both of them are used in diapers, right? So it'll just depend on how coarse or how fine it is, whether it'll be the firmer gel. Like obviously if you threw this at a student, they're gonna get it in their face. So I know that Sam wants to throw this in my face because this is her favorite demo and I took it for her today. So yeah, if you let it sit for a couple of minutes, you'll find out that it'll get cooler. And you can have your kids obviously hypothesize about, you know, what will happen if I just let this sit here for 5 minutes. They'll probably think it's going to maintain its temperature that it was already at, when in fact in 5 minutes it will be cooler to the touch than it was originally. So,
And it could also be used for doing measurements and graphing. You know, you can say, okay, if I added 10 mils of water and it got this big, measure the volume, what would happen if I add 20 mils of water or 30 mils of water? What other concepts do you think you could bring into it?
I know the 5th grade does heat transfer. I'm talking about if you have objects, you know, one next to another with 2 temperatures, that you can talk about where's the heat going. They don't necessarily do exo and endothermic, but they, you know, it's like a much more simplified kind of thing. So you can talk about what's happening to the surroundings versus the snow. So I think I'm going to totally poach this